Welcome to another deep dive. Tonight we're shaking things up a bit. We're taking inspiration from the Cocktail Party Chemistry show.
Oh, cool.
Yeah, and serving up some fascinating science about Saturn. So think of this as your crash course in cocktail party chemistry. Arming you with cool facts about Saturn's rings and icy moons to impress your friends at your next gathering.
I like it. Saturn is definitely a captivating world, especially when you consider its chemistry.
Right?
It really is like a cosmic cocktail of elements.
Okay.
You have this gas giant planet, and then you've got these icy rings, and then you've got hydrocarbon-rich moons.
So you're telling me Saturn itself is a gas giant, but its rings are mostly ice? And some of its moons are full of these hydrocarbons. That's crazy. What does that even tell us?
Well, it actually tells us quite a bit about how Saturn formed.
Oh, really?
Yeah, so billions of years ago, the early solar system was just this swirling cloud of gas and dust.
Okay.
And as Saturn formed, it pulled in all this material, but the lighter elements, like hydrogen and helium, those stayed in the atmosphere.
Mm-hmm.
But the heavier elements and compounds, they coalesced into those icy rings and moons that we see today.
So it's kind of like a layered cocktail.
Exactly.
I love that. Okay, so the rings are basically a giant cosmic ice rink made of water ice particles.
Yeah.
But are they perfectly smooth and flat? Or what's their texture like?
So that's a great question. They're actually far from smooth and flat.
Ooh.
Think of them as this chaotic dance of countless ice particles. They range in size from tiny little dust grains to chunks as big as houses. And they're all just constantly colliding and swirling around Saturn.
Whoa, wait. House-size ice chunks?
Yep.
That's insane.
And within this mix, you've got gaps and waves and even something called shepherd moons.
Shepherd moons? What are those?
So these are small moons that orbit within or near the rings, and their gravity actually helps shape the rings' edges.
How do they do that?
It's like, imagine a shepherd herding sheep.
Okay.
These moons, they gently nudge the ring particles, keep them confined to specific orbits and stop them from spreading out and dissipating.
So it's all a very delicate gravitational dance.
Exactly.
Keeping those rings nice and structured.
Exactly.
That's pretty awesome. Okay, let's move on to the moons themselves. Let's talk about Titan.
Okay.
Saturn's largest moon. What makes it so unique chemically?
So Titan is truly a world unlike any other in our solar system. It has lakes and rivers,
Yeah.
but they're not filled with water.
Wait, what? If it's not water, then what's in the lakes and rivers?
Imagine a world where methane and ethane, the hydrocarbons that are gases on Earth, they're liquid.
Okay.
On Titan, it rains methane, rivers flow with ethane, and lakes fill up with these hydrocarbons. It's a world with a hydrocarbon cycle instead of a water cycle.
So instead of a water cycle, it's got a flammable liquid cycle.
Pretty much, yeah.
That's insane. I have so many questions. Could there be life in those methane lakes? And what would it even look like?
Well, that's a question that keeps scientists up at night. We think that life, as we know it, relies on water, but on Titan, it's possible that life has found a way to exist in those frigid hydrocarbon environments.
So like aliens breathing methane instead of oxygen?
Exactly. Utilizing different chemical reactions for energy. It's wild.
That is definitely a good cocktail party fact right there. Okay, let's switch gears to a different moon. What about Enceladus?
Okay.
I know it's much smaller than Titan, but I hear it's got a pretty big surprise hidden underneath.
Oh yeah, Enceladus might be small, but it's hiding something incredible. A vast subsurface ocean of liquid water.
You're kidding. A hidden ocean. How is that even possible in such a small, icy moon?
It all comes down to tidal heating.
Okay.
The gravitational pull from Saturn and other moons creates friction inside Enceladus that generates heat that keeps the water liquid under all that ice.
Okay.
And here's the really crazy part. This ocean erupts in these giant plumes of water vapor that shoot right out into space.
Giant water plumes. You mean like a moon-sized geyser?
Exactly.
How can a moon so small have so much liquid water? And what does this mean for the possibility of life?
Well, the presence of liquid water makes Enceladus one of the most promising places to look for life outside of Earth. And these plumes act like windows into this hidden ocean. They give us clues about its composition and whether it could support life.
Fascinating. So we've got icy rings, hydrocarbon lakes, and hidden oceans. Saturn is like a giant chemistry lab in space.
What's that?
But we can't wrap up without talking about one more thing.
What's that?
The hexagon at Saturn's North Pole.
Ah, yes.
It's both beautiful and completely mind-boggling. What's the story behind that geometric wonder?
It's a mystery that's baffled scientists for decades. Picture this. A six-sided jet stream, a constant hexagonal storm, and it's bigger than Earth.
Wow.
And it's been raging for years. We still don't fully understand how it forms or why it's so stable.
A giant hexagonal storm. That's crazy. It's like nature's playing a cosmic game of geometry. What are some of the theories that scientists have come up with to explain this bizarre shape?
There are a few leading theories, but most of them involve complex fluid dynamics and atmospheric interactions. So some scientists think it's related to how Saturn's atmosphere rotates, creating these unique wave patterns that result in the hexagon. Others think it might have something to do with how deep the atmospheric jet stream goes. But honestly, even with all our observations and models, the hexagon is still one of Saturn's biggest mysteries.
So even with all our scientific know-how, we're still stumped by a giant hexagon in the clouds.
Yep.
That's incredible. It makes you wonder what other mysteries are out there in the universe just waiting to be discovered.
Absolutely. There's so much more to explore. I know, right? It really makes you realize just how much is still out there that we don't know about our own solar system?
For sure. But let's stick with Saturn for a little bit longer. We've talked about Titan and Enceladus,
Right.
but are there any other moons worth mentioning in Saturn's little family?
Oh, absolutely. Saturn has over 80 moons,
Wow.
and they each have their own unique story. One that really stands out is Iapetus.
Iapetus,
Yeah, it's got a real split personality in terms of its appearance.
a split personality. Okay, what do you mean?
Well, imagine a moon that's two-toned.
Okay.
One side is super bright, like almost as reflective as snow, and the other side is as dark as charcoal.
Seriously, a two-tone moon? That sounds so strange. What could possibly cause that?
So scientists think Iapetus is sweeping up this dark, reddish dust from another one of Saturn's moons.
Oh, really?
Yeah, Phoebe, as it orbits the planet, this dust basically builds up on one side of Iapetus and creates that stark contrast that we see.
So Iapetus is getting like a one-sided cosmic dust bath.
Pretty much, yeah.
That's amazing. It makes you wonder about how all of Saturn's moons interact with each other. Are there any other cool examples of that?
Definitely. Their gravitational interactions are really complex,
Okay.
and they can have some really fascinating effects.
Like what?
Well, some of the smaller moons, like Prometheus and Pandora,
Okay.
they actually act as shepherds for the F-ring.
Wait, hold on. More shepherd moons. I thought those only took care of the main rings.
So they do, but these moons are a little different.
How so?
Well, they orbit on either side of the F-ring, which is super narrow,
Okay.
and their gravity creates this kind of braided look in the ring.
So they're like cosmic weavers constantly shaping and reshaping this delicate ring.
Exactly. It's a perfect example of how even small objects can have a huge impact on these grand systems like Saturn's rings.
It really is like a cosmic ballet with all those moons and rings dancing around each other.
I love that analogy.
Speaking of intricate movements, let's talk about the speed of the particles in those rings.
Oh, yeah.
How fast are we talking?
It depends on how far away from Saturn they are, but they can be orbiting at tens of thousands of kilometers per hour.
Tens of thousands of kilometers per hour. Whoa.
It's a cosmic speedway up there, and they're constantly bumping into each other at those speeds, too.
So even though Saturn's rings have been around for billions of years, they're not the same rings from back then.
Exactly. The rings are always evolving. They lose particles out to space from those collisions, and they gain new material from impacts with things like comets and asteroids.
So they're in constant flux.
Pretty much, yeah.
That's so cool. I never realized how much was going on in those rings. Okay, so we talked about Enceladus and its hidden ocean.
Mm-hmm.
Are there any signs that other moons might have those too?
Potentially, yeah.
Oh, really?
Scientists are really interested in a few moons like Mimas and Tethys.
Okay.
They've seen some clues that suggest there could be subsurface oceans under their icy shells.
But how can they even tell? I mean, if those oceans are hidden under miles of ice.
Well, they use some really cool techniques. One way is by studying the moon's gravity.
Their gravity.
Yeah, subtle variations in gravity can indicate a large body of water underneath the surface.
So they're basically using gravity to see under the ice.
Exactly, and they also look for these tiny wobbles in the moon's rotations,
Oh, interesting.
which can be another sign that there's liquid water sloshing around under there.
That's incredible. It's amazing how scientists can use these indirect methods to figure out what's going on so far beneath the surface of these moons.
It really shows you the creativity and perseverance of scientists.
I completely agree. And each new discovery just makes us more curious and leads to even bigger questions about life beyond Earth. Yeah, it really makes you think, doesn't it? All these hidden oceans may be full of life right here in our solar system.
It's amazing.
It really does. Okay, so we've talked about all these amazing things on Saturn and its moons, but let's bring things a little closer to home for a sec. Have you ever heard of extremophiles?
Oh, yeah.
What are they exactly?
Well, they're these organisms that can live in really extreme environments.
Okay.
Environments that would kill most other life forms.
Like where?
Well, think boiling hot springs or acidic mine drainage or even the deepest parts of the ocean.
Wow. They're like the ultimate survivors.
Exactly. And the really cool thing is that they've evolved these unique adaptations that allow them to thrive in these extreme conditions.
Like what kinds of adaptations?
So they've got these special biochemical pathways, unique enzymes, and even changes to their physical structure.
Okay.
And all of this helps them survive things like extreme temperatures, high pressure, and all sorts of crazy chemical conditions.
That's incredible.
Yeah, so for example, some extremophiles have proteins that don't break down at high temperatures,
Oh, wow.
and others have cell membranes that can stay fluid even in freezing cold environments.
So basically, they've figured out how to hack their own biology to survive in these crazy places.
Exactly. It's a testament to the power of evolution. And, studying these extremophiles not only helps us understand the limits of life,
Right.
but it also could have some big implications for things like biotechnology and even the search for extraterrestrial life.
I see what you mean. Like, if life can exist in these super harsh environments here on Earth,
Right.
then who knows what's possible on other planets and moons?
Exactly. Maybe those methane lakes on Titan or those hidden oceans on Enceladus,
Yeah,
which seems so extreme to us, might actually be full of life forms that we can't even imagine yet.
that is a truly mind-blowing thought. So we've gone from the outer reaches of our solar system with Saturn
Hmm.
back down to Earth with extremophiles, and it's been an amazing journey.
It really
I
has.
feel like we've uncovered some really fascinating facts about chemistry, both on Earth and beyond.
It's been a pleasure chatting with you about it.
Likewise. And to all of our listeners out there, thank you so much for joining us on this deep dive into cocktail party chemistry. We hope you've enjoyed learning about all these amazing chemical wonders and that you'll walk away with some fun facts to impress your friends at your next get-together. Remember, science is everywhere, just waiting to be discovered. So keep that curiosity alive, keep exploring, and who knows, maybe you'll make some incredible discoveries of your own.